Hello, welcome to the Maths Matrix and part 4 of the fractions series where we'll be doing mixed numbers and improper fractions. My name's Rebecca and for today's lesson you'll need pen and paper. At the end of the lesson we'll also be looking at calculations involving mixed numbers and improper fractions. So if you haven't yet watched adding and subtracting fractions, multiplying and dividing fractions, then make sure you know how to do both of those things before we start. Assuming that you have been watching the other videos, just continue on in your notes and put a subtitle of mixed numbers and improper fractions. And then if you write down the number 3.5 and just put an arrow at it and put mixed number. So a mixed number is a number that has a whole number and a fraction part as well. So 5.5, 3 1/3, 20 1/4, they would all be mixed numbers because they've all got a whole bit and a fraction. If you then put 11/4 and put an arrow at that, and label that improper fraction. So if the number on top is bigger than the number underneath, so you've got a top heavy fraction, that is an improper fraction. And it's important at GCSE that you're able to convert between the two forms, that you're able to change mixed numbers into improper fractions and vice versa. If we wanted to change that mixed number into an improper fraction, if we had a cake, in fact, if we had 3 cakes to represent the 3 that's in front of the mixed number, and then we were to cut each cake into half, we'd be cutting each cake into 2 pieces. So we would have 1, 2, 3, 4, 5, 6 pieces of cake in our 3 whole cakes. And then the half bit on the end of the 3 means we'd have an extra half of cake as well. So that tells us that 3.5 equals 1, 2, 3, 4, 5, 6, 7 halves of cake. So 3.5 and 7/2 represent the same amount of cake. They just look like 2 different numbers, but they actually represent the same thing. The way that we work that out in an exam, and where the numbers are large, because we might not necessarily be able to go around drawing cake. It's all right if we're working in halves or quarters and there's not many of them, but if we were working with a number like 35 and 12/17, it would be very difficult to start drawing cakes. So what we do is we think in every full one we've got 2 halves. So in 3 full ones we've got 6 halves. In other words, we multiply the 2 and the 3 together to give us 6. And then we add on the 1 to give us 7. And we're working in halves, so the answer goes over 2. So if I was to do another one, if I have 4 1/3, if I have 4 cakes, and I was to split them into thirds, then I would be splitting each cake into 3 equal slices. So in other words, in 4 cakes, I would have 3, 6, 9, 12 slices, and then I've got an extra third as well. So 4 times 3 gives us 12. Adding the 1 on makes 13. And the question was in terms of thirds, so I'll put it over 3. So in 4 1/3 cakes, I'd have 3, 6, 9, 12, 13 slices of cake that was all divided into thirds. So if you ever can't think what to do in an exam, if you're asked to convert a mixed number and you can't remember which to times and which to add, just think of a simpler mixed number that you can draw, like 2.5 or 3.5 or 1 1/4, and think, right, if I was to cut this cake up, what would happen? And draw yourself some cakes and count your slices, and that should then prompt you as to what you do when the numbers are more complicated. So if I had 5 2/7 and I wanted to convert that mixed number into an improper fraction, I would say 7 times 5 is 35 and add the 2 on makes 37. And I'm dealing with sevenths. So 37 over 7. If I had 6 2/5, I would say 5 times 6 is 30 and add the 2 on makes 32. And I'm dealing with fifths. So that's how you convert between mixed numbers and improper fractions. So times, add on, and whatever the question was given in, that's what goes on the bottom. And if you can't remember, draw some cakes for a simpler version to prompt you. So if I give you a couple to try. If you just convert 4 2/9 and 3 3/8. So hit pause and then hit play and I'll go through them. All right, so 9 4s are 36 and add 2 on makes 38, and we're dealing with ninths. 8 3s are 24 and add the 3 on makes 27, and we're dealing in eighths. So that's mixed numbers into improper fractions. We now need to be able to go the other way. We need to be able to go from improper fractions into mixed numbers, and that's the exact opposite. So if I have 11 over 4 and I want to change that into a mixed number, if I have 11 quarters of cake, which might take me some time to draw, I apologise. So if we have a full cake, it's split into 4 pieces, 4 equally sized pieces. So if I have 11 quarters of cake, I have enough for 2 full cakes with 3 quarters left over. Mathematically speaking, what I'm doing is I'm saying how many times does 4 fit fully into 11? 4, 8, the next number would be 12. So it fits in 2 full times with 3 leftovers. So what I'm actually doing is I'm saying 11 divided by 4 equals 2 full ones, remainder 3. And because we were dealing with quarters, it's 4 that I put at the bottom there. So it's a divide with a remainder basically. And if you ever can't remember in an exam, get drawing cake on a simpler version and it should prompt you what to do with a more difficult version. So if I have 22 fifths and I want to convert that into a mixed number, 5 goes into 22 4 full times, 5, 10, 15, 20, with 2 remainders. And the question was given in fifths. so the answer will be over 5 as well. If I have 17 over 3, 17 divided by 3 is 5, or rather 3 fits into 17 5 full times with 2 leftovers, and the question was in thirds, so I'll put it over 3. So that's how you go from improper to mixed numbers, okay? So if you just have a go at, let's have 23 over 6 into a mixed number, and let's have 33 over 8 into a mixed number. So have a go at those and then hit play. So 6 goes into 23 3 full times, 6, 12, 18, with 5 leftovers, and we're dealing with 6. 8 goes into 33 4 full times with 1 leftover, and we're dealing in 8s. So 3 and 5/6 and 4 and 1/8 are your answers there. Incidentally, mixed numbers are the only time where I allow my students to write slanted fractions. I really should have said that in the adding and subtracting video and the timesing and dividing video. When you're doing arithmetic with fractions, it's much easier for yourself if you write the one number directly over the bottom number rather than writing slanty fractions. Because if you have a slanty fraction, or even worse, a properly slanted fraction like that, you don't have a top and a bottom, you have a left and a right. And it's much harder then to see when you're timesing the tops or timesing the bottoms or whatever, which is your top and your bottom. So for adding, taking, timesing and dividing with normal fractions, make sure that you have a clear top and a clear bottom, because if it doesn't make too much of a difference here in plain number, it certainly will when you get onto algebraic fractions. That's all there is when it comes to converting between mixed numbers and improper fractions. So what I'm going to do now is I'm going to put some questions on screen where you can practice converting between the two. And then after that, I'm going to put the answers up. But that's not the end of the video, so don't go away. Hit pause, do the questions, hit play, check you've got them right, and then keep the video running because I'm going to talk a little bit more yet about how they come up on exams. All right, so see you shortly. Right, hopefully you got those conversions between mixed numbers and improper fractions right. And now I just want to talk a little bit about exam style questions. So continuing on with your notes, just put note. If in an exam you are given a question involving mixed numbers, always convert to improper fractions first. After that, the usual laws of fractions apply. And then just put e.g. 3 2/5 plus 4 1/3. Now, what students sometimes say to me is they say, well, can you not just add the 3 and the 4 to make 7? And then can you not just add the 2/5 and the 1/3 in the normal way and then add the two together to get your answer? And I say, yes, you can. You can when it's adding and you can when it's taking, but you can't when it's times and dividing. And so rather than people learn two different ways of doing things, I think it's easier if you just know that when you're working with mixed numbers, it's always best to convert them to improper fractions first, regardless of whether you're adding, taking, timesing or dividing. That way in an exam, you'll always know what to do and you'll always get them right. So if I convert this into an improper fraction, 5 times 3 is 15 and add the 2 on makes 17. And I was working in fifths, so that becomes 17/5. 3 4s are 12 and add 1 makes 13, so that's 13 and I was working in thirds. And from that point, it's then just normal adding and subtracting of fractions. So before two fractions can be added or subtracted, they must be expressed over a common denominator. So I'll put each of those over 15. To get from there to there, I timesed by 3. So I need to times the 17 by 3 as well. 17, 34, 51. To get from there to there, I timesed by 5. So I need to times 13 by 5 as well, which gives me 65. And then I add those two together to make 116 over 15. Now, usually a question like that would say giving your answer as a mixed number. So I then need to work out how many times 15 goes into 116 so I can convert this improper back into a mixed number. So 15, 30, 45, 60, 75, 90, 105. So 1, 2, 3, 4, 5, 6, 7 full ones. And then to get from 105 to 116, I'd have to add 11 on so that my final answer would be 7 and 11/15. All right. I'll show you another mixed numbers one. So if we had e.g. 2 and 3/8 times 6 and a half, I'll convert. So 8 times 2 is 16 and add 3 on makes 19/8. Times by 2 6s are 12 and add 1 on makes 13 halves. And then I just times along the top. I don't know what that is in my head. So this is where your long multiplication's going to come in. So I want to multiply 19 by 13. 3 9s are 27. 3 1s are 3 and add the 2 on makes 5. Block off with a 0. 1 9 is 9. 1 1 is 1. And then I need to add those bits together. So 7 plus 0 is 7. 5 plus 9 is 14. 1 plus 1 is 2. So I have 247 over 16. Then I'm going to say how many times does 16 go into 247? This would be if they'd said give your answer as a mixed number. If they hadn't specified that you had to give your answer as a mixed number, then you'd get the mark for that. But what I'm going to do now is I'm going to put 16 into 247. So 16 into 2 goes no times. 16 into 24 goes once, remainder 8. 16 into 87, 16, 32, 48. 48, 58, 66, 66 and 16. That can't be right, can it? No. 48 and 16 will be 64. Adding another 16 will make 80. So 1, 2, 3, 4, 5 full ones. And then there'll be 7 remainders. So that will be 15 full ones with 7 leftovers, and we were dealing with 16ths. Okay, that is, I think, the only time in GCSE where you would use a remainder rather than putting 0.000, because when we're trying to convert this back into a mixed number, we need to know how many times does 16 fully fit into 247, which was that part there. And then we needed to know how many leftovers so that we could do the 7/16 part. I can't think of any other bit of maths at GCSE where you would use a remainder rather than actually the decimal equivalent, but there we did. And I didn't know off the top of my head how many 16s were in 87, so it's absolutely fine to make a list or count them on your fingers, and it's absolutely fine to make a mistake as well. As you can see, you're never too good to make a mistake. Don't worry about it, just cross it out and put it right, okay? And that's what you do if you encounter mixed numbers on exams. You almost certainly are going to encounter mixed number calculations on your exam, even if you're on an exam board with all calculator components actually. So even if you're on IGCSE and you're smugly sitting there thinking, well, I don't care, I get a calculator for both papers. Sometimes on an IGCSE, they'll say, show that, and they'll force you to do it without your calculator for the marks. On any exam board that has a non-calculator component, you are highly likely to be given 1 or 2 questions involving mixed number to be done without a calculator for 5 or 6 marks. So it's quite a decent chunk of marks you get for your fractions work, and that's just your explicit fractions work. That doesn't include other bits of fractions that might be hidden in speed, distance, time, density, mass, volume, or algebraic fractions. So it's a topic that is really, really worth knowing. What I'm going to do now is I'm going to put a set of mixed fractions questions up, hit pause, have a go at them, and then when you've done them, hit play, and I'll put the solutions up afterwards, and that'll be the end of the adding, taking, timesing and dividing with fractions work. So thank you for watching, and I will see you in the next video. Bye!